Hey everybody, this is Mr. Ainsworth, and we're going to get started here in section 4 here in chapter 7, and we're going to be talking about what are called reference angles. Alright, and after today we're going to be able to find the sine and cosine of an angle using the reference angle associated with it. And so what we're going to do is go through the procedure and figure out how to do such things. So let's start off with what we know. Let's plot a point on the circle here. Let's say that this point is point P, and it has coordinates x, y. That would imply that we have the following distances here. Okay, we know that if P is at x, y, that this has to be x in distance x, and this is y to be at x, y. We also know that this is the radius, and then from here to here, well, this is your central angle, or the given angle theta. All right. Now this is a right triangle, and so the Pythagorean theorem applies, and all your definitions that we already know apply. So let's go ahead and just review them both. We defined sine earlier in the previous section as opposite divided by hypotenuse. In other words, it's y to r. And we defined cosine as adjacent divided by hypotenuse, and then we defined that to be x to r. And we knew that from our basic definitions that we knew from geometry. And we had that acronym that we learned back in geometry. And let me get rid of that. And it was SOHCAHTOA. So we have SOHCAHTOA. Sine is opposite divided by hypotenuse, cosine adjacent divided by hypotenuse, tangent opposite divided by adjacent. From that, you could use this little triangle here and form your definitions in terms of x, y, and r. We also know that from the Pythagorean theorem here, we know that r squared is equal to x squared plus y squared. And from that, if I square root both sides, I know that r is equal to the square root of x squared plus y squared. So I'm able to find the hypotenuse or the radius at any time I want if I know x and y. We all know this. I'm just reviewing this, okay? Like I said, we know these things. All right. Now, from these definitions and from our knowledge of the sign of the coordinates in the quadrants, we can get our sign analysis. In quadrant 1, okay, quadrant 2, quadrant 3, and quadrant 4. Since x and y are both positive, okay, we know that, and the radius is always positive, okay, radius always positive here. We can form the following conclusions about the sign, whether it's positive or negative in respect to sine theta and cosine theta. In quadrant 1, x and y are both positive. So you take a positive divided by positive, you get a positive. So sine theta is positive in quadrant 1. And this is all discussed in a prior lesson. So it's positive, it's a positive number. Cosine is x to r. So cosine theta in any angle where theta is between 0 degrees and 90 degrees, that's going to be a positive value too. Why? Because x is positive. Okay? Take a positive divided by positive, you get a positive. Simple. But in quadrant 2, x is negative. And because of that, a negative divided by positive is negative. So cosine theta is a negative number in quadrant 2. Y is positive in quadrant 2, the y coordinate. So sine theta is positive. In quadrant 3, both coordinates are negative. So you take a negative divided by positive, you get a negative. So both cosine theta and sine theta are both negative in quadrant 3. In quadrant 4, x is positive, but y is negative. Now, since x is positive, cosine theta is positive, and sine theta is negative because y, the y coordinate is negative. All right. Knowing this, we can evaluate the functions at angles from 0 to 360 or from 0 to 2 pi around this circle here and determine their values or the sign, whether it's positive or negative. Knowing that and knowing your basic trig values at the multiples of 30, 60, and 45, you can pretty much evaluate any multiple of 30, 60, and 45 from 0 to 2 pi or from 0 to 360 around the unit circle if you know some basics, such as these right here. So let's get right into it, and let's take a look at what we remember from geometry. We have a 30, 60, 90 here, and if you remember, if the hypotenuse is 2, the side opposite of the smallest angle is half that, so it's 1. And to go from the smallest side to the side opposite of 60, which I call the medium length side, it's root 3. So these values 2, 1, root 3 on the 30, 60, 90 are known already. And from these angles here and from SOHCAHTOA, we can easily get some basic values for sine and cosine. So let's go through them. Let's start off with the cosine of 30 degrees. We know cosine, let me spell SOHCAHTOA here so we can see it better. Cosine is opposite divided by hypotenuse. So opposite of 30 is 1, adjacent divided by hypotenuse. Adjacent is root 3 divided by hypotenuse 2. So you have root 3 divided by 2. Whereas the sine of 30 degrees is opposite divided by hypotenuse. So, opposite divided by hypotenuse, and that's going to be 1/2. These are what I call the basic ratios for the sine and cosine evaluated at 30 degrees, or what we say pi 6. Now 180 divided by 6 is 30 degrees. So this is in radians, that's in degrees. You need to memorize these, by the way, and either memorize them or be able to draw this special right triangle here, the 30, 60, 90, and get them from there like I do. Let's switch to 60 degrees. So on 60 degrees, let's take the cosine of that, 60 degrees, or pi thirds, and notice that it changes. It's adjacent divided by hypotenuse, so this is going to be 1/2. Whereas the sine of 60 degrees, or pi thirds, is going to be different. It's going to be opposite root 3 divided by hypotenuse 2. So root 3 to 2. And let's do the same thing for 45 degrees too. So let's take the cosine of 45 degrees, and that's going to be root 2 divided by 2 because it's adjacent divided by hypotenuse. So root 2 divided by 2, and the sine of 45 degrees, which is the same as pi fourths, by the way, and that's going to be opposite root 2 divided by 2. So this is the only angle where sine and cosine are the same. Well, that's less than 90, that is. All right, and these are what I call the basic ratios that we have, and all 6 of them here. And we call the 30, 60, and 45 degree angles reference angles, because what we're going to do in quadrants 2, 3, and 4 is we're going to refer back to these to get our values and adjust the sign where needed. And because we're going to refer back to them, we call them reference angles. You can see the what's going on there. All right, so what I want you to do when you get home tonight is to make some note cards. All right, and when you do, let me put this down here, make note cards. All right, with this on the front. All right, so front is cosine 30 equals question mark, and of course this on the back side. All right, so front, back, front, back, front, back, front, back. These are your first note cards here. And then also right here on your sign analysis, make note cards. Put on the front, where is sign positive? And then put on the back, put down the results. All right, and be able to determine and remember, where's cosine positive, where is it negative? Where's sine positive, where is it negative? So note cards here too. All right, NC for note cards. All right, NC. All right, so remember these basics here. Draw the triangles when needed, and let's use them to our advantage. Now, when the angle is greater than 90 degrees, how do you find the reference angles? How do you do it? So let's go ahead and go through a little activity here and try to develop the ideas. I'm going to place P or draw a 30 degree angle here to the best of my ability. Let's see here, 30 degrees, right about there. So this is point, we'll call this P1. All right, is at 30 degrees. I'll just put that right up here, 30 degrees. And 30 plus 180 is 150, so this is at 150 degrees down here. 150. So, and then I'm going to go straight across. And plot a point over here. Call it P2. All right. Now P2. I'm going to switch colors here. You'll see why I'm doing this in a minute here, because I'm going to try to use some symmetry here. Let me see, so this is 30 degrees here, and this is also, these two angles are congruent here. They're both 30 degrees, which means this has to be, this is 150 here. What am I thinking? I'm thinking up here. That's 210. 180 plus 30 is 210. So this is 210 degrees. Sorry about that. And up here is 150. That's what I was thinking about here. So at P3, we're at 210, we're at P2 at 150, and this is also 30 degrees right here, so it's 30 degrees short of 360, so that'd be 330. So at P4, we're at 330 degrees. With these outlined, we can figure out some some decent results here and figure out how to get back to our reference angle. Now, before we do, we need to draw some triangles so I can label some coordinates of what's going on. Okay, so let's draw the 30, 60, 90 here. All right, here's the 30, 60, 90. All right, and this is 2, and this is 1, and it's root 3. And I want to be on the unit circle here so that it's familiar to you, because you guys have seen the unit circle before, and the unit circle has radius 1 and not 2. So to get a triangle here, another 30, 60, 90 triangle, such that we have a radius of 1, all I have to do is divide everything by 2. Divide all three sides by 2. Divide by 2. So 2 divided by 2 is 1. 1 divided by 2 is called a half. Root 3 divided by 2 is just a fraction. Root 3 divided by 2. So this is the same or a similar triangle here, another 30, 60, 90, but just all sides are half as long. Okay, that's all. And the reason why I want to do that is because I want to make this look like the unit circle here. I want to put 1 here, and I'm going to draw a triangle here, a 30, 60, 90 right here. So this is 1, this is 1/2, and right here, this is going to be root 3 divided by 2, the horizontal piece. Now because of that, P1 must be right root 3 divided by 2 and up a half. So it must have coordinates root 3 divided by 2, comma 1/2. And if you look at your unit circle that you were given last year or in your resources in our book here, you'll notice that at 30 degrees it has coordinates root 3 divided by 2, comma 1/2. So it makes sense, and it coordinates or corresponds to what we said earlier. The reason why I'm putting these values in is because if you look at 150 degrees here, if you drop down a vertical here and a horizontal, you notice that it's the same height. So this is also 1/2, and the horizontal piece is the same as the horizontal piece over here, but it's opposite sign, so it's negative root 3 divided by 2. So to get to P2, you're going to notice that you go left root 3 over 2, all right, and then you go up 1/2, and you get 1/2 here. So there's got to be a relationship here between the angle 150 and 30, and there is. If you notice that the x-coordinates are the same but opposite in sign, and the y-coordinates are identical, okay, they're both 1/2. We say that 30 degrees is the reference angle for 150, okay, but the question is, how do you get from 150 to 30? How do you do that? What do you do to the angle 150 to refer back to 30? Because in the future here, I'm going to take the sine of 150 and the cosine of 150 degrees. All right? So notice that they have the same, basically the same values or the same ratios, but one's opposite in the sign, which we can adjust in the future. So the question is, how do you get from quadrant 2 to quadrant 1? Well, the answer is pretty simple. All you have to do is take 180, subtract 150 to get 30. So what we're going to do is we're going to say this. We're going to let alpha here equal the reference angle, okay? Reference angle. And we're going to say theta is the given angle, all right? Theta is the given angle. In quadrant 1, theta equals alpha, or alpha equals theta. Okay, so 30 degrees, 60 degrees, 45, they're all in quadrant 1. These are the reference angles I'm talking about. Any angle between 0 degrees and 90 degrees are called reference angles. Okay, these are the quadrant 1 reference angles. Not just 30, 60, and 45, but all between 0 and 90. All right, it's just that 30, 60, and 45 are the special ones which we can evaluate without a calculator. All right, now, to get the reference angle alpha, what we do in quadrant 2 is we take 180, subtract the given angle. And in this case here that I showed, the given angle is 150, and 180 minus 150 equals 30. It's an easy way to get back to a quadrant 1 angle. Just take your given angle in quadrant 2, subtract it from 180 to get your reference. If you're in radians, your alpha is equal to pi minus theta. This will all make a lot more sense when I start applying it, and we'll start generating some values here. All right, I got to start somewhere though, so this is where we're going to start. We also say that at 210 degrees here, notice that the y-coordinate is now negative, and the x-coordinate is the same. So at P3, it's going to be, the coordinates are negative root 3 to 2, comma, negative 1/2. And you'll notice that at 210 degrees, it has the same ratios as 30 degrees. However, they're just opposite in the sign. And we say that 30 degrees is the reference angle for 210 as well. The question is, what do you do to 210 to get to 30? And the answer is you simply subtract 180. You take any quadrant 3 angle here, and you take the angle and subtract 180, or subtract pi if you're in radians, to get the quadrant 1 reference angle. So your reference angle here is going to be your given angle theta minus 180 if you're in degrees, or if you're in radians, it's our given angle minus pi radians. That's an easy way to go from quadrant 3 to quadrant 1. Okay? Now, at P4 right here, you'll notice that it has the same x value. If I drop down the vertical here, the horizontal components are the same, but the y value is opposite of 1/2. So at P4, you got to go right root 3 over 2, comma, down 1/2, so negative 1/2. So compare P1 to P4 here. It has the same coordinates, but the y coordinates opposite in sign. So we can see that 330 we can refer to 30 degrees for the angle 330. But the question is, how do you get from quadrant 4, all right, to quadrant 1? What do you do with 330 to get to 30? And the answer to that is pretty simple too. You take 360 degrees, subtract 330 to get to 30. 360 minus 330 equals 30. If it was in radians, you would take 2 pi minus that to get to the given angle in quadrant 1. So in quadrant 4, our reference angle alpha here, that's how you pronounce it, alpha, it's just a Greek symbol, is given, or is found by taking 360 minus the given angle theta, or if you're in radians, alpha is equal to 2 pi radians minus your given angle. Remember, theta is the given angle here. Okay? So we need to take these methods here and apply it so that we can handle our first example here. So I'm going to keep these at the very top so we can refer to them. Okay? Also, we need special right triangles, unless you have the unit circle in front of you. So I'll tell you what, let's draw some special rights so we can see them in our eyes here. Okay. Whoops. Change that. All right, there we go. And let's draw the 45. 45 is half of the square, so make sure you draw it correctly. So this is 45, or pi fourths. This is the 30, and this is the 60. And this is the 90, 2, 1, rad 3. This is 2, and this is root 2, and this is root 2. Okay, and this is pi 6. Okay, and notice this is pi thirds. All right, be able to draw these triangles, the special right triangles, anytime you need them. Okay, unless you have these in your head or you have the unit circle in front of you. Okay, with these triangles and these reference angle techniques, we can evaluate the sine and cosine of any angle from 0 to 360, no problem. Or actually even beyond 360, we'll just use coterminal angles as well. All right, so let's go for it here. We got the sine of 120. All right, now that's a quadrant 2 angle there. And in quadrant 2, I know that sine is positive there. So this is definitely a positive number. I'm going to put plus sign there to represent that. All right, that's equivalent to the sine of what reference angle? Well, look up here. We're going to take 180 minus our given, which is 120. So we're going to take 180 minus 120. That gives us sine of 60 degrees, which we can evaluate. And we know the sine of 60 degrees is opposite root 3 to 2. So this is equal to root 3 divided by 2. So the very first thing we do is we rewrite it in terms of our reference angle right here. Rewrite, okay, in terms of the reference angle. The reference angle, okay, and then step 2. This is step 1 now. Step 2, we evaluate. The only thing you have to do, in addition to what I just said here, is to sometimes adjust the sign. Okay? Notice that we determined that initially. I looked at the sign. I know that sign's positive in quadrant 2 because the y coordinates are positive in quadrant 2. So, but if it's negative, like if it was in quadrant 3, we would put a negative sign there. And that's how it's done. All right? You really don't have to memorize anything. You can just have the triangles in front of you, have your reference. Well, you got to memorize your reference angle techniques, and then you're good to go. Okay? So we're going to constantly refer to this. Get some practice. Now, the cosine of 150. Okay, once again, let's start off with the cosine of 150 here. Now notice that 150 is a quadrant 2 angle. And because of that, we know that the x-coordinate in quadrant 2 is negative, so therefore the cosine of that angle must be negative. So I'm going to put a negative sign here to represent that as a negative number because we're in quadrant 2. Cosine's negative there. And the reference angle is 180. 180 minus 150 equals obviously 30 degrees, so my reference angle is 30. Reference angle. So I can rewrite that as the negative cosine of 30 degrees. Once again, the reference angle is 30. I just rewrote it in terms of the reference angle. Now I evaluate. Now I know that cosine of 30 degrees is root 3 divided by 2 because adjacent divided by hypotenuse. So I get negative rad 3 divided by 2. So you first rewrite in terms of the reference angle and then evaluate. Step 1, step 2. Okay. The cosine of 3/4 pi. Now, pi is 180. 180 divided by 4 is 45. Times 3 is 135. This is 3/4 of a pi. Now, I'll also think of it like this. 1/4, 2/4, 3/4. So, pi fourths, 2 pi fourths, all right, or just pi halves, all right. 3/4 pi right here, and 4/4 pi, which is just pi. 1/4, 2/4, 3/4. This is quadrant 2. All right, it's 135 degrees in Greece. All right, now it's negative there too because we're in quadrant 2. So you have to rewrite it as negative cosine of its reference angle. Now pi minus 3/4 pi is 1/4 pi, or pi fourths. Now we know that cosine of pi fourths is adjacent divided by hypotenuse, so it's root 2 to 2. So we get negative root 2 to 2. And then the whole thing is done like this. You just rewrite in terms of reference angle and then evaluate. Two-step procedure. All right, sine of 7/6 pi. So sine of 7 pi 6, or 7/6 pi, has to be quadrant 3 because it's 1 and 1/6 pi. 7, 6 equals 1 and 1/6. So you have to go 1 pi around plus a 6 more. You're in quadrant quadrant 3. So if you're quadrant 3, sine's negative there because the y-coordinate's negative there. So I got to rewrite it as negative sine of its reference angle. Now the reference angles in quadrant 3 are found by taking the given angle minus pi, or the given angle minus 180. In this case, our given angle minus pi because we're in radians. Now 7/6 pi minus pi gives you 1/6 pi, or just pi 6, or 30 degrees in general. I'm going to keep the special right triangles up here. So what do we have? We have negative of whatever sine of 30 degrees is. And opposite divided by hypotenuse is 1/2, so you get negative 1/2. And that's all there is to it. So let's gain some more experience and let's do some more. When you take the cosine of 5 pi thirds, understanding that 5/3 is 1 2/3, you got to go halfway around plus 2/3 more. That puts you in quadrant 4. All right. You got to go halfway around. It's pi, and then you divide this into thirds. You go 1/3, 2/3. You're at 5/3 pi right here. That's quadrant 4. 180 divided by 3 is 60. Times 5 is 300. This is 300 degrees. Quadrant 4. All right, 0, 90, 180, 270. You're beyond 270. You got to be in quadrant 4. That's positive there because the x-coordinate's positive in the quadrant 4, so is cosine. So I'm going to put a plus sign just to represent that. So it's positive cosine of the reference angle. What's a reference angle? Let's look up top here. In quadrant 4, it's 2 pi minus the given angle. Okay. Well, what's 2 pi minus 5/3 pi? So 2 pi minus 5/3 pi, that's the same thing as 6 pi thirds minus 5 pi thirds. Okay, well obviously that's just pi thirds. Alright, so this is the reference angle is pi thirds, or 60 degrees. 180 divided by 3 is 60. So what is that? Well, look at the triangles again. The cosine of 60 degrees right here is 1/2. So you constantly look back at your triangles, and you can get all the values. So you don't even have to memorize. You can just look at your triangles, look at the unit circle, and figure it out. Now the sine of 240, what's that? Well, let me see. 240 is quadrant 3. Sine's negative there because the y-coordinate is negative there, so you write it as negative sine of the reference angle. You go from quadrant 3 to quadrant 1, you got to subtract 180. And 240 minus 180 40 minus 180, that's 60. So the reference angle is 60 degrees. Now sine of 60 degrees is root 3 divided by 2. So you get negative root 3 divided by 2. And that's how it's done. That's how you evaluate functions at angles bigger than 90 degrees all the way around the circle. Alright, we're going to pass up this unit circle up right now. Let's go on to the next page. You guys have seen that before. So I'm going to get into sine and cosine graphing, sine and cosine. Okay, now, when you graph sine and cosine, you need to evaluate some points. Okay, so if you're going to graph sine, where y equals, let's say, let's use theta as our variable here, y equals sine theta, where theta is the angle and sine theta is the y value. You got theta here and you got sine theta here. We're going to, actually we can graph from 0 to 2 pi. You need to evaluate at multiples of pi halves and see what's going on. And then you can determine the range and amplitude, and I'll define all these things. So you want to start evaluating and see what's going on. So let's start at 0 degrees. Alright, we know the sine of 0 degrees is equivalent to the y-coordinate on the unit circle. Now what's that? So let me review that real quick. So let me draw a little situation here. Let's put a circle here. Okay. Alright, it's a unit circle here, radius 1, so this point, 1 comma 0, that's at 0 degrees, 90 degrees, 180, okay? So up here, you're at 0 comma 1, right here at negative 1 comma 0, right here at 270, you're at 0 and negative 1, alright? Now remember, on the unit circle here, let's just label that 1, it's a unit circle, the sine of the angle is equal to the y-coordinate. The cosine of the angle is equal to the x-coordinate. You guys remember me saying that in previous lessons. So the sine of 0 is equal to the y-coordinate, so it has to be 0. That means that the sine function passes through the origin. Alright. What is the sine of pi halves? So the sine of pi halves, the sine of pi halves is up here. It's the y-coordinate, so it's got to be 1. So we got to plot pi halves comma 1. So let's do that. Write pi halves up 1. And keep going around. Well, how about pi? What's the sine of pi? Well, right here, the y-coordinate is 0 again. So sine of pi is 0. So you got to graph pi comma 0. So it goes up and back down. It increases and then decreases. So far I have a curve. Okay? Got to hit that point. And then what is it at 3/2 pi? Down there at 270. So what's sine of 3/2 pi? When you look over here, the y-coordinate is negative 1, so it's equal to negative 1. So write 3/2 pi down 1, down right about here. And then lastly 2 pi. What's the sine of 2 pi? Well, it's equal to, 2 pi is coterminal with 0, so it's got to be 0. So 2 pi comma 0 is back here. So it decreases and then it increases. Right there is one period of pi. Okay, so from 0 to 2 pi, from 0 to 2 pi, we call the period. After this, it keeps on repeating itself, okay? Because we can always refer back to the coterminal angles between 0 and 2 pi. 5 halves is coterminal with pi, 5 pi halves is coterminal with pi halves. And 3 pi is coterminal with pi because you just subtracted 2 pi here. All right, so we can just translate these points over and get more points for the sine curve. All right, but the period is 2 pi, p for period. It's called the fundamental period, 2 pi radians. The amplitude is seen here. It's the distance above the wave axis, which runs right through the wave. This is called the wave axis. And the amplitude is right here. We'll call that capital A. Capital A represents that distance, which is 1. So the amplitude is 1. You can see it right here, too, as well. That's also the amplitude. And let me see, the domain, well, theta can be anything. You can take the sine of any angle you want, okay, negative or positive, so it's going to be all reals. All right, we use the symbol capital R for that. The range is bounded. The maximum is 1, the max, and the minimum is negative 1. So we say that the range, or the set of y values, range from negative 1 to 1. So we write it like this, negative 1 less than or equal to y less than or equal to 1. It's called a range. think y values. Domain, think x values, or theta in this case, because I'm going to use the variable theta. All right. If you want to graph more than one period, just repeat this pattern. Okay, this point right here transfers over here. This point transfers over here. Just add 2 pi to pi to get 3 pi. Add 2 pi over here, and you get down here at 7/2 pi comma -1. Then add 2 pi to 2 pi, you get 4 pi. So if you want to graph more than another period, maybe graph 2 periods, you can just repeat the points and then continue. All right. So forever. This is the sine of theta. All right. So we have 2 periods. Another period is from here to 4 pi. All right. Second period here. So period equals 2 pi. All right. We're going to do the same thing for cosine. So what we want to do is graph cosine now. Y equals cosine theta. And plot points and see what happens. All right. So let's start at 0 again. 0 degrees. What is cosine of 0 degrees? Well, you know that cosine of 0 degrees is the x-coordinate at 0 degrees, and the x-coordinate is 1. So cosine of 0 degrees is 1. We're going to plot at 0, 1, which is on the y-axis here, okay, or the vertical axis. And then keep on doing this like I did above here. So pi halves, what's cosine of pi halves? That's up at the top at 90 degrees here. 90 degrees is equivalent to pi halves. All right, and the cosine, or the x-coordinate, is 0 there. So we say that cosine of pi halves is 0. So we plot pi halves comma 0, which is right here. And then you evaluate at pi. So we have cosine of pi. That's at 180 here. 180 and pi are the same thing, and the cosine, or the x-coordinate, is -1. So the cosine of pi is -1. So right pi, down 1. And then at 3/2 pi, we have cosine of 3/2 pi. What's that? You're down at the bottom of the unit circle at 3/2 pi. The x-coordinate is 0 again, so we say that's equal to 0. So right 3/2 pi comma 0. And then lastly, you got 2 pi here, cosine of 2 pi. What's that? It's going to be the x-coordinate again, because this is coterminal with 0, and that's going to be 1. So 2 pi comma 1. You start sketching. It's decreasing here. It's not linear, so don't draw a straight line. It's a curve. If you look at a computer-aided drawing program, or use your calculator, it's curved. Notice that I'm plotting 5 points for each graph. That's the minimum number of points that you need to plot to graph a good, single period of either cosine or sine. So plot, let me write this down, plot 5 points minimum. All right. And then again, if you want to draw another period, you could take these points and repeat them. And then you can draw another period. So you just continue it down here. Go ahead and draw the graph. The period is seen here, the distance between 0 and 2 pi. It's the same period. So the fundamental period we say is 2 pi. It repeats after 2 pi radians. The domain is a set of all reals, just like the sine function, because you can take the cosine of any angle, whether it's negative, 0, or positive. So all reals. Okay, or you can use the capital R. The amplitude is seen by looking at the distance above the y-axis here, or here, or here. This is all the amplitude. The amplitude is 1. And the range is the same as the range for sine. The maximum is 1, and the minimum is -1. So the y values range from -1 to 1. So we say that the set of y values here ranges from -1 less than or equal to y less than or equal to 1. Or in other words, you can say -1 less than or equal to sine theta less than or equal to 1. And up here, the same thing, -1 less than or equal to, not sine, but cosine, sorry. I was looking above here. -1 less than or equal to sine theta less than or equal to 1. All right, so similar but shifted. The cosine function is actually sine function shifted over. Okay, pi halves radians. The same amplitude, same period, but it starts at 0, 1 as opposed to the origin. All right, that's how you graph sine and cosine, and you're just going to have to practice that and generate it. In the future, you're not going to need a table of values. You're just going to plot 5 points, 1, 2, 3, 4, 5, after labeling the axis, and do your quick sketch. This is not needed. This table of values is only needed in its development, like when I teach it. But after that I teach it, we don't use the table of values anymore. All right. And what I want you to do now is try your homework assignment here. Do your best, and I'll see you tomorrow.